It's really great to be here. I'm going to talk about all sorts of different things. I'm going to talk about package development, leaflet, interactive maps, and also about air quality. So hopefully, while some of this might be quite domain specific to what I do, you might get some good stuff out of it. But the first thing I want to do is talk about what air quality actually is. Because some people think when they think about air pollution, they're thinking about climate gases, right? They're thinking about things like carbon dioxide or methane. I had a conversation with someone in a break and they said, oh, you're talking about carbon capture? Not that. It's a sort of common thing. When we think about air quality, kind of the way I think about it is climate gases contribute to global warming, they contribute to climate change. And further down the line, of course, we care about that because it's bad for humans, it's bad for animals, etc. Air quality gases have a much more direct effect on our health. So if you breathe in carbon dioxide, you're perfectly fine, unless you breathe in too much of it, of course. But if you breathe in some of the species that I'm interested in, they will harm you in some appreciable way. So in the UK, typically the pollutants we care about are particulate matter. So that's things like little particles, solids and liquids that are in the air. They can come from all sorts of different places. That could be from car exhausts, it could be from industrial activity. You can see some examples up here, so I don't even go through all of them. They can come from a myriad of sources. And the other one is NOx, oxides of nitrogen. And they are combustion products, right? They typically come from cars, some industrial activity. So they're the key ones. But there are a myriad of other ones, right? There's things like sulfur dioxide, that's sort of less of an issue nowadays, methane, hydrocarbons, etc. There's all these different things in the atmosphere that are harmful to us if we breathe them in. And the second thing to say is how harmful are they, right? Because a lot of things are harmful for us, but we have to have a sense of perspective. We can't stop everything we do because some things are bad for us in some way. How appreciable is it? How important is it? This is a graphic from the UK Health Security Agency, back when they were called Public Health England, and that kind of summarises some of our sort of statistics that are good to wheel out. So long-term exposure to air pollution in the UK contributes towards deaths, but even beyond deaths, we're looking at things like heart disease, we're looking at strokes, asthma, cancers. And really the evidence keeps stacking up that air pollution is bad for in all sorts of ways. Right, recently some examples on Twitter I saw that aren't just people on Twitter, it's from academic articles people were talking about, not just some random guy. Osteoporosis in postmenopausal women, mental health, things like anxiety and depression, all these things are exacerbated by air pollution. And one sort of slightly sad fact is that in the UK we have the only person, I think, in the world, or the first person in the world to have air pollution or air quality on their coroner's report, and that's actually a young girl. So even though, you know, maybe relative to hotspots like, say, Delhi or some megacities in China, for example, where we think, oh, the air quality is really poor, it's maybe a little bit better here, but it's still bad enough, and it's still something to deal with. So that was the slightly morbid background bit out of the way. There's code now, we're back on home turf. This is a summary of some of what we do at Ricardo, and this is all for the government, so if we have to measure our air quality. This is a map of all of our sort of national level air quality monitoring sites. So this is where a lot of the data I use comes from. I'll just zoom in so you can see more. I've not clustered these to really deliver the message of how much is going on here. The red ones are our sort of big UK-wide ones, and the other colours are the individual sort of subcomponents of the UK there. As we zoom in, I can zoom into London, say, and we can have a little look. I'll just click on a random one. Southwark, Old Kent Road, and you can see all these are different, right? They have different classifications. There are traffic sites, there are background sites, rural, suburban, industrial. They're all kind of in different geographical locations, different local authorities are responsible for them. They measure different things. They're nitrogen dioxide and particulate matter, the one I was talking about before. And all of these are effectively continually generating data, so continuous time series that are constantly being measured of all these different pollutants in all these different locations. Each one is bespoke, it's different. Not every traffic site's the same, not every background site's the same. And this is, as I've said at the bottom there, this isn't even all of it, right? There are networks that are run by local authorities that aren't run by Ricardo or any kind of national level people, and also there are non-automatic ones. We measure things like heavy metals, hydrocarbons, etc., that don't continuously produce data but have different sort of time signatures there. So That's what we're looking at. It's all this data that we continuously measure, and it's all important, right? It has health implications, public health implications. So my role is to work with it. I'm an air quality measurements data analyst, and that's what it says on Microsoft Teams. And really, my work is all about leveraging R to communicate this to stakeholders. I think about the public being the distant client, even if the immediate client is DEFRA or a private company or whatever. It's people, right? People breathe stuff in, and then we have a duty to tell them what they're breathing in and how to mitigate the poor effects of air quality. So that can be things like authoring reports. We've already had a brilliant talk about that, so I'm not going to go into too much detail. We produce data visualizations, dashboards, do various sort of data analysis, and also develop new tools. That's something I like to do, is to more readily output some of the things we do our work better and quicker and more efficiently, etc. Another thing that I do, that I was told to mention, is I do training too. So we do training really in R, well, all sorts of different things, but I'm responsible in part for some of the R stuff, to help other air quality practitioners better understand their data using R and R Studio. And you can see some of our past clients, DEFRA, the UK HSA, Neath Port Talbot, which is a really interesting air quality situation down in Wales, Clean Air Society of Australia and New Zealand, talking about working with people in Australia. That was some early mornings, and some others as well. The platform we do that through is called EMAC, the link's on the bottom there. This is all on my GitHub, so you can find it, and I'd be told off, I think, if I didn't mention where you could look for that. That's my only plug. Talked about dynamic reporting already. I don't think we have to go into detail about this. We had the great talk, and really we do very similar things. We automate this. Our data, because we have control over it, we are responsible for a lot of these measurements. We have our house in order, so the data comes in pretty consistently, so we can quite readily just have automatic reports that can be summarised for a local authority to say this is what your air looks like. We can also do more ad hoc reports in response to what are called pollution episodes. So that's sort of a one-off situation where the air gets really bad. So that could be, for example, particulate matter on firework night or bonfire night, because of course all that beautiful soot has to go somewhere and it can be breathed in, or even ozone episodes during heat waves and in various situations like that. So I'm not going to go into detail about that. If you do open this on your own computer, you can click through that and read the full report if you'd like to. It's a nice example. But really what I'm here to talk about is openair. So I'm not the sort of lead author, as it were. Professor David Carslow at the University of York and Ricardo, he authored this over a decade ago. Openair is pretty much the go-to air quality package in academia, public sector, private sector. But one thing about it is because it's quite old, it's over a decade old, there are some odd things about it. One is that it uses lattice over ggplot2 because it was written in a much different landscape, a different ecosystem to what we're used to now. And really what I try to focus on is we don't want to let it languish, we want to keep developing it, we want to make it useful, we want to integrate it with all these cool new developments in the R ecosystem. Dynamic reporting is one of them. So what do we do with that? And I've just on the screen there, I've got two examples of the kind of thing openair can do. One thing is these sort of calendar style heat maps that people tend to really like, and there's some kind of robust kind of trend setting as well. If you do end up looking at documentation for openair, there's some things in there that are a little bit odd nowadays, like a function that just does scatter plots, but it was written in a time where ggplot couldn't do it in 2 lines, and it was a huge faff on. So that's just a bit of context in openair. As a little aside, you might be sat there thinking, I don't really care about air quality, and this is a huge waste of time, and I'd rather be at a break or having more sandwiches or whatever. It can give you access, in a kind of sister package WorldNet, get you access to time series data. So if you're someone who, I don't know, teaches time series analysis, or one of the best bits of the R community is people like to write blog posts and YouTube videos and all this kind of good stuff, and you want access to just some data that's sort of dummy data set or something, you can import your local air quality monitoring station and see what you can do with it and have a play. It makes it quite easy to do so. Okay, sort of functionality here, and the map can be generated on your side as well that I showed before of all the different stations. The WorldNet package I'm not going to really talk about, but that does the same for world meteorological data. So the key thing I really wanted to talk about is how we're doing an advancing directional analysis. So the obvious one is the trend analysis, right? How are things changing? Broadly, they're getting better, I'm sure you're happy to hear. But directional analysis is the kind of more interesting one, which is where the pollution we have, where's it coming from? So these kind of directional analysis plots that openair puts together typically look, I'm going to bring them both up, they're typically kind of polar plots in the sense they've got a polar coordinates rather than Cartesian. And in both cases here, I'll zoom in on one of them just so you can have a little look. This is a windrose, say. You kind of got your spoke axes there, you've got your compass directions, north, east, south, west, and then your radial axes that go out, that's the frequency of counts. So that is showing that most wind at this site is coming from the southwest, is really how to read that. Some people think it means the wind's going to the southwest. It's just a industry standard thing. I get confused sometimes as well. And there's various different kind of directional analysis markers we employ. The limit of kind of these, that one on the right is showing, instead of wind speed, it's showing pollutant concentrations. We kind of want to be able to capture pollutant concentrations and wind speed and wind direction, because that'll kind of tell us where's, at least points in time where concentrations are high, what are the meteorological conditions, and that can help us kind of understand where pollution is being blown in from. So one way to do that is through a plot like this, again, something that openair automatically sort of creates, is a polar frequency plot. So just to explain what this is. You're still northeast, southwest, that's still the same. Your sort of radial axis going out, that's your wind speeds, and your colours, this sort of almost polar heat map concentrations. So the way I'd read that is effectively from 0 meters per second of wind, so when it's still, up to about 10, where the kind of red blob is, when the wind is coming from kind of the southwest. That's when our highest concentrations are. And that's kind of how I'd read that. And that's really useful because it helps us actually answer questions of if we want to lower this NOx concentration or this particulate concentration, we can try and work out where it's coming from. Though that is just to explain what's going on. Typically we sort of smooth it out with a two-dimensional GAM to get a sort of smoother surface that doesn't have a big hole in the middle. And we're going to see more of these. But the limitation of this, this is where openair sort of stops and the new stuff starts. The limitation of that is, you might say, okay, I kind of get it, everything's coming from the southwest, that's pretty bad when the wind speeds of a certain thing, but what is to the southwest? What's the actual source? It lacks that level of context. So what we've been doing this year really is quite rapidly developing openair maps. So what this does is it takes kind of the old, sounds a bit dismissive, but this sort of traditional kind of package that's written in leaflet and written in lattice, and it's been around for a decade, and brings it up to more modern day. We're able to put it in dynamic reports and the like, and combine it with leaflet to get these interactive maps. So here we get a lot more context as to what's going on. So here we can physically zoom in, we can have a little look, we can see the context in which this air quality is being measured. So, for example, this one here, that's a background site, that's in a sort of school grounds. And that kind of pattern there tells me really all the sources are very local there. I'd probably fully expect that's from cars, people dropping off their kids, picking stuff up. Meanwhile, others would tell me that's Marylebone Road, a very polluted road in London. That kind of offset pattern tells me that's a roadside source as an air quality practitioner because it's coming from one direction in particular. Over there in Bloomsbury, you've kind of got this situation where there's a bit of a local element there, but it's also blowing in from the north-west. So maybe from Euston Station there. This data is sort of what's built into openair maps. It's slightly old for a purpose. Don't make any conclusions about how you walk home or anything today based off this. But really, this is what we're looking at, right? This is a helpful advancement because it helps people understand the sort of context of the plots I've already shown. We do have to be very careful to say it isn't the case there's this big cloud of miasma hanging over there. That's not sort of a spatial component, it's a wind speed component. And really, we've been developing this quite rapidly in a way. It languished in a sort of pre-release state for a while, with just being able to effectively do what I showed there. That's sort of all it could really do. But we've been advancing it quite a lot, so we've added new functionality to it, we've added new sort of abilities that I'll demonstrate in a second. But what I've really liked about this is my first CRAN package, which is always very exciting. Being in the position to teach it, to circle back to what I said before, really helps me understand where to advance it. Because I keep thinking, oh, it's finished, it's done. There's nothing really more we can add. And someone says, oh, can you do this? And you sheepishly say, no, but not yet is the answer, and I'm able to implement it and really work with the people who are actually using it. So what I thought I'd do is show some examples of it in use and how we use it, because it can go much further beyond what I showed before, and also look at some more recent data that's maybe of interest. So in this case, this is a single site. This is in Oxford. It's an Oxford roadside site. And what this shows, I mean, it's a single one, right? Most of the pollution's coming from an easterly direction like that. In reality, this is probably, not to get too in-depth, you can get a street canyon effect that circulates air, so it might not be the best example for the directional side of things, but here I've got an option to show different years. So this to show sort of through the pandemic, here are sort of max values and the 250 mark. As we progress down, as I click through these, 2020, activity drops, we're not allowed outside anymore, we're now down to 100, 150. And even as we progress further, we're still not quite at those levels we were before the pandemic. Maybe activity has changed on a sort of semi-permanent basis now. Maybe we're not going to go back up again. Or indeed, maybe the buses are electric or something. That's the other thing that we don't have access to. We have to do our separate research. Yeah, I think that's that for this one. This sort of layer control is quite nice. The top right and sort of leaflet language is a layer control menu. I did some teaching for people who looked at, for example, forest fires, and they said it would be really nice to have a pre-burning event during burning and after burning, so we can see how the pollution situation changes through a forest fire, for example. There's loads of different examples of how that's useful. Another one that's really nice is this kind of triangulation. So this is, these are some sites near, in Scunthorpe, near the steelworks. And you can kind of see when you have multiple ones of these on a map, you can see is there a dominant source? And in this case, there probably is, because in a sort of basic way, they're all pointing in the same direction. So I'd sort of assume if we were going to work with the people of North Lincolnshire to try and find out where their sort of dominant sources of air pollution are, this would be a nice way to, you know, see where the first port of call should be to try and work it out. If you work for the steelworks in Scunthorpe, I'm not criticising you at all. This is very basic. Please don't come after me during the break. This is just an example of how we could employ this in a simple way. And indeed, sometimes you can, what Leaflet lets you do is flick between different base maps. You can have a satellite view, and in this case I noticed you can kind of see the plume. So in some ways this is a bit, not worthless, but it's all evidence, isn't it? So there's an example, and that's a really nice use case of it. Other things you can do, right, is before it was just polar plots, those kind of smooth surfaces. There are different markers we can use too. So these are polar annulus markers, and these show, instead of sort of wind speed being on that radial axis, we've kind of got hours of the day. So it sort of shows you, for example, over here on the left-hand side, we've got this is NOx, I believe, yeah, this sort of combustion source. We can see the sort of traffic AM peak there. So that's probably when people are dropping their kids off, going to work, etc. Whereas this one here in Marylebone Road, pretty much high all the time. So again, it's nice to compare between sites. But what's also nice is we can compare between pollutants as well in a really interactive way. So if I flick over to sulfur dioxide, we can see there's barely a change. So that might tell us as air quality practitioners that it's coming from a similar source, right? If it looked drastically different, like say I'll swap over to particulate matter, that's telling me that's coming from somewhere totally different. And even that's useful to me as an air quality professional, to say that in this case, particulate probably isn't coming from, say, cars. It's coming from probably out of London, to be honest. They're all pointing in the same direction. When all sites behave the same way, that might be telling me that's a transboundary pollution event. That's coming from outside in, rather than being a more local one. Yes, I appreciate. I've not got loads of time. People talked to me about, oh, I'm really looking forward to it. People love maps. People really like maps. I don't know what it is about maps, but general public loves maps. Leaflet makes it easy to put together maps. So this is an example. Maybe you can look through in your own time. Here I've just got a data frame with latitudes and longitudes, and you can see if I didn't space this out, effectively 3 lines. You've got an interactive kind of web map there that I think a member of the public would look at and think, wow, that's really cool, and you must have a proper JavaScript developer working on that, and actually no, it's sort of me not doing a lot of hard work in particular. It's my favourite thing. It looks impressive, but doesn't require much work. So don't tell my boss any of that. Otherwise give me more work to do. And just to round off in the last sort of 30 seconds, The way in which openair maps works, this is a quite complicated flow diagram, maybe just look at it in your own time if you're interested. We do a lot of data nesting, so we nest each site. So we have latitude and longitude for each site, then a nested data frame with all of our quality information in there. We use that nested data column to make the plots, and also we use the latitude and longitude to create a unique file path. Keeps everything organized. We can then just save the plot to the path, and then in the leaflet side on the bottom there, when we add the markers, we can just point it at that column of paths, and it keeps everything nicely arranged. So I think that's my time. I've talked about some future directions, maybe I'll leave them up just to not overrun too much. I'll not be the first person to overrun today. And I'm open to any questions either now or in the break.